This video will guide you through the notes for exponential functions. So by the end of these notes, you should know what are the characteristics that define an exponential function, or what makes an exponential function an exponential function. So an exponential function has these general formula that looks like this. F of x equals a times b to the x. Here, a and b are numbers. Reminder, the symbol f of x is just like a y. And your graphs are going to look like one of these four. So when I'm about to describe these graphs, but I want to go over the vocabulary words I'm going to use first. So I'm going to use the words flat, steep, and steeper. And here are the Chinese translation for those three.
平坦的陡峭的陡
Here are the Vietnamese translation for those three words. Flat, steeper, steep.
bằng phẳng dốc hơn dốc đứng.
In Spanish, flat is plano. Steeper is más empinado. Steep is empinado. All right. So if you have an exponential function that looks like this, where it's starting off positive and going from left to right, it's getting bigger the whole time. It's increasing. But at the very beginning, it is pretty flat, and then it just gets steeper. Or it starts off positive and it increases, but how fast it increases, or it's getting bigger, but it's increasing how fast it's getting bigger as you go left to right. So flat to steeper. Or you can have a graph that looks like this, where it starts off positive and it is getting smaller the whole time. At the very beginning, it's getting smaller very quickly, and then it's getting smaller still, but not as quickly. So it has a very steep slope at the beginning and a very flat slope as you go towards the right. This right here is called exponential increase or exponential growth. This is exponential decline or exponential decay. Your graph could also look like one of these two, where you start off with basically the same sort of thing, but when you start off negative. So here you start off with a negative value, and it is getting more negative faster and faster and faster as you go towards the right. It's very relatively flat on the left, and it's relatively steep on the right, or the other way around, where it's relatively steep at the beginning, and then it gets flatter and flatter as you go to the right. Okay, so this is what the graph basically looks like. This is the equation for exponential functions. Let's talk about what values a and b cannot be. So for this general equation for exponential functions, the a can be any number except a cannot be 0. Your b number, which is called your base, cannot be 1, but has to be greater than 0. So basically b cannot be negative, b cannot be 1. And let's sort of look at what happens if we don't follow these. What happens if they didn't have these as restrictions on the function? So if it says a cannot be 0, and the reason a cannot be 0 is if a were 0, then the graph would just look like this. It would look like a line, or it would be linear. And the reason is because if we have our equation here, and I change a to 0, you have 0 times b to the x. Well, you know 0 multiplied by anything is 0. So then the equation just becomes f of x equals 0. And so remember, f of x is like a y, so y equals 0 is just a horizontal line. Y equal a number is just a horizontal line. If we let b equal 0, then a similar thing happens. So if b were equal to 0, your graph would look like this, where you basically have a line with a hole at x equals 0. So once again, it would just be linear. And the reason that happens, if we have our general equation here, and I were to change the b into 0, well, b to any exponent, except for 0, so b to basically any exponent, 0 to any exponent, will basically equal 0. Like 0 times 0 times 0 times 0 4 times is still 0. And we know 0 times any number a just gets you f of x equals 0 or y equals 0. So once again, you have that same horizontal line. The reason it has that hole there is because 0 to the 0 power is actually undefined. So it has this little undefined hole at x equals 0. And because we already have equations for horizontal and vertical lines, because we already have equations for lines, we do not want this to be a line. We want this to be exponential and look like one of these graphs. So that's why we say a cannot be 0, b cannot be 0, b cannot be 1 for basically the exact same reason. If we change your b into 1, 1 to any exponent is 1, and then 1 times a just becomes the number a. So you will have y equal a number, which is just, once again, a horizontal line. Okay, the last restriction is that b cannot be negative. B cannot be less than 0. And if we have b less than 0, then the graph is just crazy. Crazy, crazy, crazy. All over the place, and is discontinuous. It's not, it doesn't connect. Let's give let me show you what happens if we try to have b equal a negative number. So here, I just had the equation. Here, I supposed, or assumed that I picked some numbers here, and I changed my b into -2, just because multiplying by 2s are easy. And then I changed a to be 1, once again, because multiplying times 1 is an easy number for me to do. So if we try to have b equal a negative number here, okay, well, -2, and I'm going to simplify this. Multiply by 1 doesn't change anything, so let's just have -2 to the x. If I have a -2 to the 0 power, anything to the 0 power equals 1. So x equals 0, y equals 1. If I have -2 to the 1 power, then that equals -2. If my x is 2, -2 times -2 equals +4. -2 times -2 times -2 3 times equals -8. -2 to the 4th power is 16. -2 to the 5th power is -32. Okay, let's put that on a graph and see what that ends up looking like. So if I had, okay, So when x equals 0, y was 0. X equal 1, y was negative 2. X equal 2, y was positive 4. X equal 3, y was negative 8. X equal 4, y was positive 16. And then x equal 5, y was negative 32, which is somewhere, I don't know, way down here. So it just kind of goes up and down all over the place. Obviously, you can tell that this right here is not going to connect to look like one of these 4 graphs. No way. It even actually gets crazier than this though, because this sort of looks like it just goes up and then down and up and then down and up and down, which is kind of crazy, but it actually even gets crazier than that. So let's look at the numbers here between 1 and 2. Okay, so what happens in this little spot between 1 and 2? Is it just like this smooth, goes down and goes back up? Well, if you put in your calculator, x equal 1.1. So if you were to type in your calculator negative 2 to the 1.1, you actually get an undefined value. But if x is equal to 1.2, you actually do have a value, around 2.3. If x equals 1.3, then once again it's undefined. X equals 1.4 is now negative 2.7. So it was negative 2, undefined, then positive, then back to negative, all within a span between 1 and 1.4. So in between this little spot right here, it went negative, positive, negative with undefineds in there as well. So long story short, if you end up having your b be a negative number, your graph will just be crazy. It will not be continuous. You'll have all these undefined little spots everywhere. So long story short, this is your general formula for an exponential function. And in the definition of this, your a cannot be 0. Your b has to be positive and cannot be the number 1. Okay, let's have you do some work now. You've heard me talk for a while. So I've talked about what numbers a and b cannot be. Let's talk about the numbers a and b can be. So a can be any number except for 0, and b has to be a positive number but cannot be 1. So what I want you to do, you're going to end up going into a graphing program online, and you're going to try to figure out what values for a and b will make the graph look like this, exponential growth. Which values for a and b would make the graph look like this here on the right, exponential decay or exponential decline. Which values for a and b make it look like this? Which values for a and b make it look like this? By the way, here I have written the definition for exponential growth and decline, but just know that that's this one and this one. Okay, so the program I'm going to have you use is Desmos. So either you can Google Desmos online calculator, or you can just type that in. And you're going to type in here different values for a and b and see what type of graph it gets. So you're going to basically say, like, when a is like these types of numbers and b is like these types of numbers, I'll get a graph that looks like this. In Desmos, in order to write this multiply sign, that's going to be shift 8. And in order to do exponents, you're going to do the shift 6. So for example, y equal, let's say a is equal to 5. I'm going to put shift 8 to do that little multiply sign right there. And let's say 5b, let's say it's 2. And then we're going to do exponent. So I'm going to say shift 6, and it'll go all the way to the exponent up here. And then you write your x up there. And that's what the graph looks like. So put different values for a and b, and figure out which values for which combination of values of a and b get you this one, this one, this one, and this one. Pause the video. Do that. Hit play when you're ready to continue. At this point, you should have the values for each of these, right? Let's go on to page 3. Okay, so learning goal for page 3, you are going to, hopefully by the end of this part, you'll be able to figure out or determine what happens, what's the effect on the graph when you change the coefficient, that's the a. So as you change the a, what will happen to the graph? What will be the effect on the graph? You're also going to be able to hopefully determine, as you change the base, what happens to the graph. All right. So using the stuff you just figured out about these 4 graphs, answer this question. If a is if you have a as a positive number, how does changing the value of a from one positive number to another positive number, how does that affect the graph? Answer that question. Pause here, answer it. Hit play when you're ready to continue. All right. Answer the next 2 questions. What is the y-intercept for this? So where does it cross the y-axis? That's the vertical one. Where will this general formula cross the x-axis? Since we have here the general form, y equal a times b to the x, your answers will include a's and b's. After that, you're going to answer this question. So this question basically says, you know this. You know that 2 to the x equals 7. If you knew that, what would, and for this answer right here, x is about equal to 2.807. If you knew this information, what would be the approximate answer to this? What would x about equal? And you have to use this to figure it out. Pause here, answer those 3. Hit play when you're ready to continue. All right. So last thing for this page is I want to talk about these 2 words, domain and range. So domain is what values can x be. Range is what values can y be. What you're going to do is you're going to actually go to this page right here. And for each of these 4 graphs, I want you to write what the domain is, what is the range. So here, write domain, and then what values can x be. And this is just basically looking at the graph and writing the domain. So write what the domain is, what values can x be, write the range, what values can y be. Pause and do that for each of the 4 graphs. Pause the video here and do that. When you're ready to continue, continue. Okay, now that you've figured out the domain and range for these 4, I want you to go to page 4 of these guided notes and just continue answering the questions.